Welcome to Google Sunnyvale for the hands-on with Kubernetes and Istio from ReactiveOps. My name's EJ Etherington. I'm the CTO at ReactiveOps. Here's some information about me. I'm not terribly exciting, but the people I work with are very exciting. About ReactiveOps, so we're a services organization. We provide services for Kubernetes. DevOps is consulting, and DevOps is a service, and that's basically our mission statement. We build and maintain Kubernetes so you don't have to. We're experts in it. We know it as well or better than most, and we can help you out, making it better, making it work for you. If you have any questions about our services, you can see the gentleman in the red shirt back there. That's Brian. He knows everything about everything we do. So talk to him if you're interested. So today we're here to talk about Kubernetes. Create a Kubernetes cluster in GKE. That's why Brian asked about the account. We'll deploy a web application there, talk about what it means, what we're doing, and then we'll do some Istio work. Show of hands, how many people are currently running Kubernetes in production or otherwise? People who don't have their hands raised, by the height of your hand, express how much Kubernetes experience you already have. Like, I know everything. I've done a walkthrough once or twice. Great. So the first part will be kind of 101-y basic Kubernetes discussions of topics. So maybe a refresher for a lot of you, maybe new for one or two of you, and maybe boring for some of you as well. Just bear with us. We'll get to the more advanced and exciting topics at the end. We need to make sure we get everybody up to speed. So part one, an introduction to Kubernetes. We're going to talk about what Kubernetes does, or what it is, what it does, who it's for, and how it works. So according to the website, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications, which is a nice succinct way of saying it does stuff. We'll get into more about what it's doing and how it's doing it in a minute. There's a little quote I like to say, it's Greek to me. Kubernetes is the Greek word for helmsman, pilot, sailor, etc. And so if you know Shakespeare, it was Greek to me. So about Kubernetes. What is Kubernetes? Kubernetes was developed at Google. It's based on a container orchestration project they built for their internal stuff called Borg. They donated it to the CNCF in 2014, I believe. So now it's a Cloud Native Computing Foundation open source project. They built it to orchestrate microservices in containers. And as anybody not using Docker as part of their primary workflow? Is Docker new to anybody? Great. So we know what containers are, and we probably know about microservices, so we're in good shape there. It's important to remember that Kubernetes is a tool for operations and developers. It solves a lot of problems, and it solves problems in both of those camps. So maybe we're all DevOps engineers, maybe we're operations engineers, maybe we're developers, but we can all benefit from the utility and the tooling that Kubernetes provides. It really is solving problems for people. Problems of availability, scalability, discovering, and networking. Making sure that your microservices are always running. Making sure that when you get a load spike, your microservices scale appropriately. Making sure that you don't need to configure your IP address for each one of your services. So service discovery is a big component. And then there's also some networking that's under the covers. It depends a little bit on how you implement your networking, but there's a lot of cool features in the networking stack as well. If you are an operations or IT, it's solving your problems. It's fault tolerant. It can replace and repair an entire node, or just a service, or just a single container. So it's self-healing and fault tolerant. If it's configured properly, it will automatically scale to the workloads. So if you receive an unexpected burst of traffic, your nodes aren't going to fall over. You'll just add more. You'll add more instances of your application or your microservice, and then consequently add more nodes to your Kubernetes cluster, which results in fewer midnight pages, which is always good. You don't need to get paged if a node falls over because it'll get replaced. You don't need to get paged if an instance of your application dies because it'll get replaced. You don't need to get paged because all of your boxes are running at 90% CPU and you're worried about latency. It'll automatically scale for you. If you're a developer, Kubernetes is solving your problems too, because you don't necessarily need to talk to somebody else to deploy your application. You can push it directly to a Kubernetes cluster, and whether that's a development environment or a local Kubernetes like Minikube or something like that, you can always be sure that your container, the code you're running in that container, is going to run in Kubernetes. The version of Kubernetes you deploy to as a developer is the same version of Kubernetes, potentially, hopefully, probably, that you're deploying into production. So you have a lot more confidence that your development environments and your staging environments and your QA environments are more production-like. And that can help you deploy faster with less risk. For the users, if we have a web application or any sort of application with users, whether they're public or internal to your organization, when your services are up longer, when they self-heal, when they can scale automatically, you get more uptime, makes your users happy. If your users are external, happy users can be increased revenue. Your website's up better, your e-commerce site is selling more, your software as a service runs better, faster, more reliably. People want to pay for that. When you have, and because of the scheduling that Kubernetes does, which we'll talk more about in a bit, but because of that scheduling, you can reduce your cloud spend or reduce the number of VMs you have to run in a data center and reduce the cost. So if you're making more money and spending less money, that's a good thing overall for the business. Any questions about any of those top concepts? Great. So feel free to raise your hand if anything comes up. If I talk too fast and you want me to repeat it, if you have a question on the topic at hand, raise your hand or just call out a question. That's totally fine. Interrupt me. I don't mind. I'd rather answer your question when it's topical than at the end. This is sort of a simplified, high-level picture of the Kubernetes architecture. Can everybody see it okay in the back? Great. On the left, you have the Kubernetes master, which is sort of the control node. It is where the API endpoint is, your kube controller manager, the etcd data store, where all of sort of the state for Kubernetes is stored to do its operations. And then on the right, you've got a series of different nodes in this case. So we have Kubernetes masters and Kubernetes nodes. On the nodes, the kubelet runs, and that's sort of the resource manager and the scheduler for each one of the nodes. And then there's a networking layer called the kube proxy. It's a basic, most simple way that services get their traffic in Kubernetes. Some people call them minions. It's called minions here, but the general terminology is nodes. Inside Kubernetes, there's lots of objects, or some people call them primitives, and this is how the configurations, the information you send to Kubernetes, to the API server, for it to do what you want it to. In this case, a Kubernetes primitive called a pod, it's sort of the fundamental unit of work inside Kubernetes. It's as small as you configure. It's a set of one or more containers running in a shared network space. So any containers running in a single pod are available to each other on localhost, but they're isolated from other instances of the pod from a network standpoint, other instances of the service, of the application. They can share files across, and they share a network, but it's sort of as small as it gets. We'll interact with pods a lot. It's how you know that something is running. The information and the events are connected to pods. But we typically don't configure or create pods manually. We use deployments to do that. Deployments is just one of the objects that will create pods in Kubernetes. There are several others, but deployments is probably the one you'll use the most and the most that you'll interact with the most. It manages pods. So the deployment is what says, hey, I want 2 replicas of this container exposing this port with this environment variable. It's kind of a very small YAML chunk. If you're not, as you're probably already aware, pretty much everything in Kubernetes is YAML, so we're going to be looking at a lot of YAML today. You upload this YAML to the Kubernetes API. It says, great, here's a deployment. I'll send these pods out. Put these pods where I can. So state's managed by that spec. The deployment, when configured properly, will scale up and down when you have a horizontal pod autoscaler attached to it. And we'll look at those when we deploy a web application later. And you can use this deployment to roll back. So if you've created a deployment and it broke, you can roll back your deployment as well. The next level, so we're sort of going from the bottom up, the pods being the most basic, and then the deployment, which is probably the most common way you create and configure pods. And then above that, we have the service. There's a few different types of services, but they all have some similar characteristics and build on each other. A service definition will define access to a pod. You'll give it a name, and you'll say, I want these pods based on however you label and select your deployments. I want these pods to be in this service. And it creates an intra-cluster load balancer or an IP address. It also creates a DNS entry. And it can create a cloud load balancer for you with certain configuration items. The three types of services are cluster IP, node port, and load balancer, of which the cluster IP is the default. What a cluster IP means, so again, you're routing to pods, which are instances of a deployment. It creates an intra-cluster IP address. It routes to pods. It doesn't create an external node port, so there's no external way. There's no way external to the Kubernetes system, Kubernetes network, to route to this service. But it does create that kubedns entry. So when your pod is deployed, when your service is deployed into Kubernetes, you can access this service at service name, whatever that is. We'll look more into the actual implementation of these later, but be aware that the very basic one is cluster IP. Building on that, the node port type service also creates an external port on the node. So you can actually access the service based on the IP and external port of that node if you wanted to use that kind of networking. This allows you to get to that pod from outside the Kubernetes network stack if you wish. So other VMs in your cloud instance in the same VPC can do it. If you want to manually create cloud load balancers or things like that, you can have that as well. But that should be unnecessary because there's also a load balancer service type. And what this will do is actually go out to your cloud provider, in this case GCP, and will create the load balancer for you. You can do various configuration options on the service description, and it will change settings, make it open certain ports, make TLS, SSL, upload the cert, where's the cert, etc. You still get the intra-cluster IP, you still get a node port, and you still get the kubedns entry. But when you want, the most basic way to expose a service is using a type load balancer. Any questions about that? Another way to expose a service to the world is with an ingress object. There are many types of ingresses. The most common is probably the Nginx ingress. It's essentially a configuration for a reverse proxy. It will also create a cloud load balancer, but it is URL aware. So you can have it be, you can route different URLs to different services inside your cluster. So there's lots of reasons you want to do this, but it's basically a reverse proxy fan out for your microservices. This way you don't need to have a different DNS entry for every single one of your services. You can have them all behind a single cloud load balancer and have the ingress configure, send traffic at URL foo to the foo service and bar to the bar service, etc. There's lots of different types of ingresses. Istio itself has a specific ingress class, which we'll look at and create later in the afternoon. But just be aware, they essentially all do this sort of reverse proxy fan out for your services. Any questions about ingress? Great. There are other primitives, other objects. The ones on the left here are ones that create pods. Daemon set is a type of deployment, a type of pod set will run one instance of that container, of that pod, on every single one of your nodes. Great uses for this are sometimes API servers want to run this way. Monitoring software where you need to make sure you have an agent on each one of the nodes, things like that. A job is almost the opposite. So it runs one instance, one pod to completion, and then it's done. You can set it to restart if it fails and configure it for things like that, but jobs are something like Ruby on Rails migrations maybe. If you're going to deploy Ruby on Rails here and you need to do a migration, you might run a job to do the migration. and then deploy the Rails framework. Cron jobs, like they sound, it's a job that runs once to completion, but on a cron schedule. Stateful sets are kind of a fun one. They allow you to create cloud volume-backed pods, where when the pod restarts, it will get connected when it restarts, and maybe it gets moved to another VM, but it will get reconnected to the same volume that it was before. So that is one way to run stateful services, databases, Redis, Kafka, you name it. There are reasons why you want to be careful about running stateful services in Kubernetes. You need to, it's kind of a different management style, and you need to be very aware and careful about that. It's a little bit beyond what we're going to get into today, but stateful set is the Kubernetes object that automatically creates cloud volumes and attaches them directly to the pod, and the data will survive a restart. Other objects on the right are more about configuration, with the exception of the namespace. The namespace is an arbitrary network delineation in Kubernetes. It comes out of the box with kube system, kube public, and a default namespace. Kube system is where the system level stuff goes by default. Typically, default is where everything else goes when you interact with a Kubernetes cluster, unless you tell it otherwise. Today we'll be working within a couple of different namespaces. It's really helpful to not use the default namespace. If for no other reason than when you want to clean up the work you've been hacking on, you can just delete the namespace and it will automatically clear out everything. And until recently, if you deleted a GKE Kubernetes cluster, it would leave the cloud load balancers orphan them. So now, instead, you would have to delete the namespace, and it would delete those load balancers. Very recently, they've changed that behavior, so we're in better shape. You won't have any cloud load balancers hanging out there for the next 3 months, and then before you realize your Google bill got high. So it's important to remember that the namespace is arbitrary delineation. It's not a secure boundary. It's useful for when we get into RBAC usage, when it role-based authentication control or authorization, but there's almost always a way to access cross namespace boundaries, especially by default. Config map and secrets are both ways to upload a configuration document. In a secret, it's usually obscured using base64 encoding, but secrets are not inherently secure, at least not inherently more secure than a config map. And persistent volumes are created by stateful sets usually, but that you can create them without a stateful set automatically or manually, and that's creating a cloud disk essentially. It doesn't have to be in the cloud, but since we're at Google, we'll talk about cloud stuff primarily. Interacting with Kubernetes is done through a tool called, I call it kubectl. I've heard all of these different pronunciations: kubectl, kubectl. I say kubectl. I've heard kubecontrol. I don't care what you say. I believe that kubectl is the official one. I'm going to say kubectl because I can't bring myself to say kubectl that much at once. Stick to whatever your Vim versus Emacs version of the pronunciation of this is. Now you know what I mean when I say kubectl. Great. So any questions about Kubernetes, high level what it's doing, and why it's awesome to use? I'm doing a great job. I probably just need to stand closer to the microphone. I like to wander around. I'll try and be better. Any other questions besides talking louder? Yes?
One question, where does the headless service fall under the types of services which you're talking about?
The headless service?
Yeah.
Can it be more specific? Like
So when you say the cluster has equal to none, so you can communicate through DNS data, but I don't know where it falls under the different kinds of services, not what it's wrong.
So I believe the question is like, why would you use a cluster IP type service, or how?
No, why would you use a headless service basically?
Oh, that's the cluster IP is the headless service that you're referring to, right?
Headless is an option.
Okay.
So that if you don't have the load balancer out front, it goes directly to the pod. I believe that's the case, right?
I don't know, that was the question.
Okay. I haven't used those. I'm not familiar with that. very specifically. We can talk later if I can familiarize myself with it, and we can discuss. Any other questions? Great. So now we're going to walk through creating a GKE cluster in Google. It's very simple. We're going to just use the console for it. As Brian asked, everybody already has an account set up, and probably not your first GKE cluster anymore. This is an old slide. So let's have a look at the console. Does anybody not know how to get to this page in GKE or GCP? Okay. Open up your Google Cloud Platform console, log in, select whatever project you're going to work on. Everybody see this page okay? Great. The hamburger up in the top left in the navigation menu. And then you can scroll down to, it's under the compute section for Kubernetes engine. Everybody good? Anybody not there yet? Great. So it's as easy as clicking create cluster. Just give it a quick name. And we'll just walk through the options and what we're choosing. I'm just going to create one that's a single zone versus regional, because it's not important for me for it to be a multi-master, multi-region cluster. If you need a high availability cluster, you'll need to do regional so you can create multi-master. I'm going to go with 197 for the Kubernetes version. There are some options in 197 that will make automatic injection of the Istio container work better, so we're going to go with that. So we're working with Istio. Single CPU machine type, that's fine. A size of 3 is fine. If you're running this in any sort of production-like environment, enabling automatic node upgrades will be nice. It will automatically upgrade the version of Kubernetes when they move to the next higher default version. However, if you do that, be aware that Google will shoot a node in the head occasionally. It will drain and coordinate, but if your applications can't survive automatic management of that in that way, it'll be problematic. I'm going to disable legacy authorization, enable logging and monitoring. And we don't need to choose additional zones for this or alpha clusters. Disable basic authentication, so 3 zones. For our purposes today, it's not important to be aware that if you are doing multi-zone in this way, it's going to multiply your bill. Let's see. We don't need a private cluster today. Default networking is fine. We do want to enable network policy. We'll be working with network policies, both of Istio and the web application will deploy in a little bit. Network policy allows you to define access over the network for different services. And everything else should be in good shape. Any questions about the options we selected, why we selected them, and other opportunities for customization?
Can you walk through one more time again?
Sure. Let's see. Just go back up the top. So the name is pretty obvious. The description is pretty obvious. Again, we went with zonal, so we're being a single zone instead of across a region by default. That has to do with how they manage the masters. I'm going to do US Central because it's the default zone. Going with the cluster version of 197 because it has some features that make Istio work more easily for us today. It's one major version higher than or minor version higher than the default. The node image, going with the default container optimized image here, that's recommended by GCP and GKE. Starting with a minimum size of 3 nodes. Leaving automatic node upgrades disabled because this cluster won't be around very long. I don't care if it gets upgraded automatically, but if you are running in production, you may want to have that set up. Basically going with some of the defaults here. So enabling automatic node repair, again, probably not important for us today, but when you're running these clusters in production or production-like environments, you want them to fix themselves. Disabling legacy authorization. GKE is particularly cool because they have logging and monitoring built into the cluster through Stackdriver. You do have to pay for it. You have to pay for the monitoring aspect of Stackdriver, but the logs come for free. We're not going to select additional zones because it's not important for us today, but if you are running large workloads in production, of course, you might want a more high availability cluster and have your workloads spread across multi-zones in case that comet hits that one building that one time. We're not going to enable alpha features in the cluster. However, if you do choose to enable alpha features, yes?
So I see options for multi-zone. Can I do multi-region on the console here, or is that?
Not. That's interesting. Interesting. I don't think so. The regional thing is something we haven't played with very much with
So
GK.
if central or west goes down completely, then that was it.
Yes.
You could do a federated cluster.
That's a possibility, but we're not going to cover federation today. And that wouldn't be in this setup anyway. You'd have to set up a separate, you have to do that separately from the console setup for the cluster.
How do you choose the cluster version and what's the significance of it? Which one to pick?
Of the Kubernetes version?
The cluster version.
Cluster versions?
Yeah. The one we picked on top. 1.9.
Oh, the cluster. That's the version of Kubernetes that's running. 1.8.10 is the GKE default right now. I'm using 1.9 because it has features that allow us to use Istio in a more streamlined way. That's why I'm choosing 1.9. For at ReactiveOps, we typically stick to the default version that Google has suggested because they have written it. I don't have in my head all the change logs for each one of these versions, so I can't tell you why I might choose 1.8.12 over 1.8.10. But the big difference is usually API objects and availability of certain, resiliency and availability of certain types of Kubernetes objects.
What's the best place to start if I want to know the difference between the
Between the versions?
yeah, between the two versions?
I'm not sure there's an easy place to start, but if you keep an eye on the change logs for the Kubernetes release schedule and read a lot of blogs and things like that. Where were we? Let's see. So we are in Stackdriver logging and monitoring. We'll leave those on. We can add arbitrary labels, which I'm not going to do today. Additional zones, alpha features. Oh yeah, so I was talking about alpha features. If you enable alpha features, they will turn your cluster off in 30 days. So for fun, for experimentation, by all means, enable alpha features to see what they're doing. But that is, if you need to run an alpha feature in production, don't, because they'll just turn your cluster off. Client certificate, that's an authorization. We're turning on auto scaling because we're going to do, hopefully, simulate some scaling events later this morning. Setting a cap of the cluster size to 3 nodes. We're not using preemptible nodes, and we're not messing with the disks. Let's see. The private cluster that's in beta, that means it doesn't have a public API endpoint. For our purposes, I'm not concerned about that. It's a temporary cluster. Google's sort of their philosophy has been make everything public and secure it. So having a not publicly accessible API endpoint is new to them. So we're working on that. If you do that, you'll need a VPN of some into the VPC to access the API. I'm not going to get too much into the Google networking stack. This is essentially the default VPC we'll deploy this cluster into. We can define a subnet. We only have one right now because it's just the default. We need to enable network policy here because we're going to utilize network policy in the demonstration later. Network policy allows you to cordon or delineate what services can talk, what pods and deployments can talk to each other. So you may not want all of your services to be able to access all of your all of the other services. You can define limits around that.
Is that something that Istio relies on?
I don't think the Istio route rule object relies specifically on the network policy, but we will be toying with network policy in the demonstration in a bit. The route rule, which is Istio's implementation of network policy, is done through the Envoy proxy and doesn't rely on the Kubernetes networking stack, or the control of network policy by the Kubernetes networking stack. Great. One really great thing, so you may be thinking, great, I can click a UI on a web page, but how am I going to create these, how am I going to do infrastructure with this? How am I really going to do DevOps with this? Of course, there's a command line. Terraform works, although not terribly well for GKE clusters. But one great thing about the the Google console in general is they provide you with a way to look at, in this case, the REST call. So if you can copy and paste this into a window, and if you're authorized, it'll create that cluster for you. Or the Google container G-Cloud command line. So I find this very handy because I can just click through a web interface once, don't have to read the docs. I don't need to dig into each one of the options and accidentally miss one. Copy that, paste that, understand it, throw in some variables, and then suddenly I've got something like automated cluster management. So to me, this is a very useful tool when you're building a pipeline. Yes?
So if we choose multiple blocks, does it add labels to the nodes?
Does it add labels to the nodes? If you choose multiple zones, does it add labels? I'm not sure if it add a label to a zone label of some kind. I'm not sure if it's going to add a label for you so you can determine which node is in which zone. It may. Cool. Just close that and we'll click create. So while that'll take about 5 minutes to spin up, while that is creating, we'll go back to this and talk about why GKE versus other forms of Kubernetes, whether you're running in AWS with kops or anything like that. Amazon's coming out with their EKS, who knows when in the future. I haven't gotten to see it yet. Even we at ReactiveOps, although we work closely with Amazon a lot, they haven't given us access, and I find that rather telling currently. Google's been doing this longer. They built this. They know more about it. They have all the Google engineers. They're managing it on their infrastructure. Google wrote a huge portion of Kubernetes. They're coming with a lot of experience. So that alone has always made me feel to trust the GKE clusters more than some hand-rolled versions, especially if you're doing Kube the hard way versus something like kops. Kops is great. This is easier. When you're running Kubernetes on GKE, it also helps with the authentication and authorization. You have built-in IAM support, which if you are doing other cluster management software, you need to either configure or roll your own. So in this case, if you're going to configure RBAC, you can already use your Google users to put the IAM roles around your Google users to affect how they can access this cluster natively, automatically, just fine. There's much less involved in creating a cluster. We don't need to learn a third-party tool. We probably already know how to use G-Cloud, or at the very least, I know how to click buttons in a UI. To set up Kubernetes clusters and other cloud providers, it takes a lot more background knowledge and work. GKE is taking a lot of that work out of it for you. The automatic cluster upgrades can be really nice. You know that because the cluster version is being managed by Google, there's a whole team of engineers that you don't have to know about or worry about that says, okay, 1.9 is ready for prime time, we'll make that our new default version, and then we'll upgrade all your nodes for you. And as long as your application is resilient to a certain degree, while it does that rolling of the nodes, it sort of happens behind the scenes with very little, hopefully, potentially, no downtime at all. And in our experience, it's been very reliable and resilient. And being able to just click a button and set up autoscaling is pretty sweet, without having to deploy extra add-ons into your cluster. let's see, has that done yet? Is anybody's cluster not creating? Any issues? Still working? Okay.
No, but it's just not. It's just finished.
Question.
Yes.
So once I set up the multi and I set up all the basic features for my cluster, is there a way in production to go back and alter any of those settings?
You can alter certain settings after you've created your cluster through the UI and through the use of gcloud. The GKE interface makes it difficult. There's certain things you can't modify or mutate. So, for example, node groups, certain values like instance size for a node group, you can't mutate in place. You have to create a new node group and then join it to your cluster, which will happen automatically.
I think so. In case you use any of the alpha features that GKE provides and you don't like it, and you ended up using it in production,
You can't turn that.
you might as well just spin up a new.
Yeah. I personally feel like Kubernetes clusters are disposable, ephemeral. Depending on how you choose to manage them, that may or may not work within your management style. But when they're this easy to set up, then making them ephemeral and making your deployment declarative, making your DevOps strategy declarative, and making your cluster ephemeral can solve a lot of those headaches where you don't need to worry about mutating things in place. There are reasons why you wouldn't do that. That's not a hard and fast rule, but that's kind of my basic philosophy around them when possible. Cool. So my cluster is done creating. How is everybody else doing? Thumbs all around? Cool. We're going to set up a work environment using the Google Cloud Shell, which is another really handy tool that Google provides, so that it really works well for me because I don't need to worry about what versions of anything you're running on your personal laptop or help you set up your terminal. We can just click this button up right here, little bracket with an underscore, and it automatically spins up a really small VM in the cloud that we have. It's a web UI, but it's a shell on that, and it already has kubectl installed, it already has gcloud installed, it has git installed, it has vim installed, it has most of the tools that you're going to need to interact with your cluster. Anybody not able to pull up a Cloud Shell? Mine's pretty fresh, so mine's quick, but it can take a few seconds to start up as they boot up that VM. And there's always a possible for conference Wi-Fi problems. So I'm going to pop this into its own window just to make that a little easier. Is the text large enough and visible enough for everybody? I can make it bigger or a different color if needed.
It's good enough. It's good enough.
Good enough. Cool. So to connect to our cluster, so to configure the kubeconfig file, we're just going to click the connect button. We can run it directly in Cloud Shell. Click that. That'll open a new Cloud Shell. But I'm going to copy and paste this because that process will work locally if you have gcloud set up on your own machine and you're authorized, but it'll also work in Cloud Shell. So I'm just going to copy this, go over to the Cloud Shell window. So now our local environment here in the Google Cloud Shell is configured to talk to the cluster we just created. That drops a file, as I'm sure most of you are aware, in .kubeconfig. So that's the YAML file that defines access to our Kubernetes cluster to the kubectl binary. Our cluster cert, our cluster name, our username, etc. Anybody not have that? Great. So now we're set up. We're ready to deploy things to our Kubernetes cluster, interact with namespaces, and interact with the cluster in general. So the next step we'll do, oops, got our Cloud Shell, looked at the kubeconfig. You can also configure your kubectl using an environment variable called kubeconfig. At ReactiveOps, we leverage that extensively because we work with 10, 20, 30 clusters every day. So being able to switch rapidly back and forth between clusters that we were interacting with is very useful, so we set environment variables. We'll look at context. Context define a cluster, a username, and a namespace. So that's how we'll, when we create our K8s Workshop namespace momentarily, instead of having to set the namespace flag with every command, we'll just set our context so that we can simplify the number of commands and the amount of typing we have to do. So now, let's see how we on time. It's just about 11. Great. We're going to deploy a simple multi-tier web application specifically built for this sort of workshop. It's not fancy. It doesn't do anything. Doesn't look good, but it works just fine. So we'll start by cloning this repository into the Google Cloud Shell. Does anybody need help with Git in any form? Great. I love it when people come knowing what they're doing. Anybody not have it? Feel free to move on. Great. This is the basic web architecture that we're going to be deploying. Little blue octagons inside the dotted hexagons are pods of the web app. So we'll have multiple instances, multiple replicas of the web app container. It's a simple Sinatra app. And there'll be a master-slave Redis configuration in the back end as well. Nope, not a break yet, sorry. You should be so lucky. So I have already cloned this. Go to my K8s Workshop. And I'm going to open up Git, and we'll just look at some YAML files. I'll use the Git web interface. Feel free to join me in the web or look at it in Vim, whatever works for you. We'll be looking, well, that's far too small. That's probably a little big. In the K8s Workshop complete folder, so this is fully configured YAML files that'll deploy natively. If you want a little bit more of a challenge, you can follow along with on your own time with the assembly required version of this, where you'll actually need to interact with the YAML files and make up your own values. Today we're just going to look at the complete to simplify things. And we'll start with the namespace. We talked a little bit about the namespace and how it's an arbitrary network division. Inside a single namespace, services are available at their service name for DNS. You can access services across namespace boundaries with a longer URL that includes the namespace. That's why I say it's not really without extra configuration, namespace boundaries aren't inherently secure. This is probably the simplest Kubernetes YAML object we'll look at today. You got the API version, kind that it is, and then metadata and a name. So this will, when we upload this will create the namespace for us. So I'll do that now. So I'll do kubectl apply -f when I can type. kubectl apply -f namespace.yml. So what we're doing, kubectl is uploading this YAML file to the Kubernetes API. The Kubernetes API is parsing that, recognizing that, and then creating the object that we're asking it to. In all cases, we'll be essentially uploading a YAML file of some kind, and Kubernetes will be attempting to make the world look like we want it to. In this case, we want the world to have a new namespace called K8s Workshop. Great. So now if we do a kubectl get namespaces, kubectl should tab complete for you, both the verbs and the objects. So that'll help you not type as much. We'll see we've got the default namespace, the kube public and kube system I mentioned before, but also the Kate's workshop. Now if we want to deploy things, create objects inside the namespace, we use the kubectl apply, and we can use -- namespace or -n and pass that argument. Alternatively, in the case of our Redis deployment, we have the namespace defined. So if I do kubectl apply this file, this will get uploaded and created in the Kate's workshop namespace. Generally speaking, I don't configure the namespace hard-coded into the objects unless I am 100% sure that's what I want. Instead, I pass it in the command line so that you can have the same object apply to multiple namespaces and make your operations a little bit easier. You don't have to manage as many files. In this case, we're doing this with Redis so that I'm sure that it all goes to the right place to start with. While we're here, let's have a quick look at this deployment. We talked about deployments earlier. You're probably familiar with them already, but let's just have a quick overview of this. So in this case, we have our deployment. It's a the file is a object of kind deployment. We have a name, Redis primary, and we're asking to deploy to the Kate's workshop namespace. We want one replica of each of the pod. We want to apply these labels to the pod, so Redis primary backend. We'll say the pod should have this spec. The pod should have this container named Redis. So that when we look at the pod, the containers running inside the pod, one of them will be called Redis. And we will use this image. And we'll talk about resources and requests a bit more in depth later. But in this case, we're defining more that the pod should respect. So in this case, we're requesting 100 milli-CPU of space resources on the server, and don't schedule me anywhere that we don't have at least 100 milli-CPUs and 100 megabytes of memory. Also, be prepared to expose this container port, 6379, which you should recognize as the Redis port. Yes?
Can you go back? What is the API version? Why is that kind of beta 1? Are you using something that's not available?
This might be an older version of a deployment. The API versions are essentially, they define what URL endpoint this gets uploaded to in the Kubernetes API. Different objects are created under different API endpoints. In this case, I'd be willing to bet that there's duplicates, essentially, API endpoint duplicates for this version. I personally don't know a good way to just sort of always know what API endpoint you should use. I tend to copy and paste from other people's work on the web, quite frankly. That doesn't work when you're creating your own endpoints, API endpoints, but when you're in there creating your own, you actually know what your API endpoint will be. So that's kind of a long answer. Short answer is I sort of copy and paste from the web. If I go and look at the Kubernetes code and I find one of their example deployments, and I basically change the values as I see fit. Okay, let's see. Let's also look at the Redis replica deployment. It should look very much the same, only we give it a slightly different name. The labels are slightly different, so in this case our role is a replica. So this is the logical distinction between pods that are configured to be the Redis primary and pods that are configured to be the Redis replica. And the important distinction will occur at the service level. And the configuration is a little bit different here. So this env block is one way to configure environment variables in the pod as spec'd by the deployment. There are other ways to configure environment variables and do other configuration changes we'll look at in a moment, but this is sort of the most basic hard-coded way. This is kind of equivalent to hard-coding something into the configuration file for your service, but at the environment variable level. So in this case, we're saying get host from the environment. That's specific to the Redis replica container. And then the Redis master service host, we're saying go to the service called, or go to the URL Redis-primary, and that's where the Redis master is going to be. Those are specific to configuring Redis. All I want to take away from here is that you've got an environment variable name and an environment variable value, and that's the way that we're configuring the containers inside this pod for this deployment. Yes. Where do we get the template? Like I was saying before, the typical way that I do it when I'm creating these is I find one and I copy it, or now I have a wealth that I have worked on. The documentation for Kubernetes has gotten a lot better in the last 6 or so months. So there's actually a lot of good examples in the Kubernetes documentation to give you the basics as well as the exhaustive list.
So when we have Kubernetes tool, it doesn't have the standard template, we can copy and change it.
When you have a Kubernetes, what, I'm sorry?
When you have Kubernetes tools, they don't supply the standard templates.
No, the tools that we'll be looking at today don't provide you with a way to easily template values into a deployment, say. There's sort of a workaround which we'll look at where you can do a kubectl create and feed it some very basic information and then get it back and output it as YAML. That's sort of a workaround, but it won't necessarily have all of the values you're looking for. So you'll still need to do a significant amount of sort of document reading, finding and replacing, and it also has a bunch of extra information in it. We'll get to that when we interact with it a little bit more, but I'll make sure to call it out.
Images used there are the standard containers, the existing containers, or they are specifically created for this template?
These are standard containers being hosted by Google. I'm not even sure why we chose these so much as that they just work. You can pull images from any image repository for any of your deployments. You may need to authenticate to your container registry in order to pull from them, and that's sort of a separate configuration, but it doesn't matter where you pull your images from to Kubernetes. Yes?
What's the CPU 100M mean?
It's 100 milli CPUs is the milli, so 1/1000th of a CPU, so we're looking at 100,000ths of a CPU.
Wow.
Redis doesn't take much resource. We'll talk more about what the resources means when we get to that, and what a milli CPU actually amounts to is sort of a hand-wavy concept in Google land. It depends a lot on what VM hardware it's running, or what hardware it's running on, what type of VM it's running on, how many cores are there, and what core architecture is running behind the scenes. So it's not a perfect thing. Any questions about deployments? Yes?
Are the labels have the role and here predefined, or they are just user-defined key values?
Can you ask that again, please?
The labels?
Yes.
Like app, role, and here, are they predefined by Kubernetes, or they are just any key value that user might want?
Yeah, good question. They are any key. It's like key value tagging or labeling system. So Kubernetes will apply some labels on its own, but the ones we're configuring, this is how I'll look at services next, and I'll show you the value of the labels. But in this case, these are user defined. We define them to say this pod should have these labels on it. A great segue into the services. Thank you. We'll look at the Redis primary service definition. So you'll notice it also has the same labels, but down here we have these selectors. And so the service knows which pods to route traffic to, because these selectors say, look for labels, look for pods with these labels and select them to send traffic to. And it can, you can use as many as you like, you can be as specific as you want. You can have one service route to different deployments based on the selectors. There's lots of magic you can do in here. We're going to do pretty straightforward today, but be aware you can do a lot of stuff. Yes?
Is this an AND relationship, so all the labels have to match on the pod, or is it like a for either of the labels?
It is, it's AND, but if you have say you have a pod with 3 labels and a service with 2, then the pod with 3 labels, and if as long as the 2 selectors on the service match 2 of those. I'm not saying it's very well. It's additive, not exclusive. So if there is a label on a pod that doesn't exist in a selector, it's not going to prevent the service from connecting to it.
Okay, but if there's another third label, does it still select it? Let's say two labels match, a third one doesn't.
Then it will not. So it needs to have all of them match. All of the selectors need to have a match in the label, but not all labels on the pod need to be selected for a service throughout there. So for example, if our pods, our deployment spec was labeled Redis backend, or Redis primary backend, but our service didn't have that role in it, then it would route. It would still route to it, but it would route to all instances regardless of what the role was. So you can get creative there if you want to do some blue-green deployments and things like that. Although I wouldn't recommend it. We'll look at other better ways to do that this afternoon. Any questions? Oh, services. So we still have the same labels. We give it a name, we give it a namespace, etc. And we're saying, defining ports, saying the port inside the service is 6379 and the service port should be 6379 as well. Yes?
So we're not specifying what type of service we're creating. So what is it going to?
By default, it will be cluster IP.
Cluster IP.
So that's the cluster IP doesn't get a node port and doesn't create a cloud load balancer. But it does create an internal load balancer. So the service, inside the Kubernetes network, there will be an IP that round robin load balances to the instances of that, to the pods of that. They're selected by the service. And it's all typically done with IP tables behind the scenes.
I have a question.
Yes?
So, could you go to the previous page? So here you have mentioned app, role, and tier. So in app, it's as an application or it's a random name? And if that Redis as application, then what other application can be used?
So the labels are arbitrary labels that we're applying so that we can do selection. So app, role, and tier are not important to Kubernetes specifically. Kubernetes doesn't care about the label key, but because we use those keys, we need to also use them for the selector. Not sure I answered your question. The app is not a Kubernetes keyword. It's a key that we have defined to use for our labels and selectors. Yes?
So, I'm a little confused about the Redis primary deployment.yaml and service.yaml. What's the purpose of the two different YAMLs?
The deployment configures and says, I need these pods to be running. And the service says, this is how I will access these pods. So if you just deploy the pods with no service, there will be no way to access them inside the Kubernetes network.
But so we have to
Well, not no way,
redefine
but
the labels in both YAMLs. Why is that? Why cannot that be just part of the service? Why does that have to be part of the deployment?
the deployment gets labels, and the service has selectors and labels. So in this case, the service selectors define which pods of the deployment to route traffic to. It's like a set of instructions. And we gave the service the same labels because we're labeling our service, but that actually isn't important for the pod selection. Let's see. So let's also look at, skip network policy for now. We'll do a little bit of look at the horizontal pod autoscaler. In order for your applications to horizontally scale automatically, you need to deploy a horizontal pod autoscaler. It's pretty simple. It says when the CPU is above 20% of our requested limits, and we're targeting the deployment called Redis replica. There's a lot of configuration you can do around this based on like how long it takes to ramp up and when instances get created, how many instances will get created at once. But this is a very simple one saying, when you get 20% of that requested limit, then we'll add another instance, add another pod. You had a question over here first.
Is there a way to scale the nodes?
Yes, and I'll talk about that in a moment, but definitely, yes.
Can you do it also memory as well, or just the CPU?
You can do it with memory as well. And there are Google just added support for custom metrics natively as well, so you can build out custom metrics for scaling.
So when does it scale down? Is that same threshold? Versus the 20% it scales down?
Essentially, yes.
There's no way to gracefully scale down. Like if I have job running, the moment it goes to the 20%, it just gets good.
So that's an interesting question, and it's kind of a deeper topic than it seems on the surface. But the Kubernetes will send a SIG term to your running pod, and how your pod respects or acts when it receives a SIG term defines its shutdown behavior. If it just up and dies, then it's poor application design. Your pod should respect SIG term and do the appropriate action with the data they're handling at that moment. But that's really up to your application design. Kubernetes can be configured to wait a certain period of time, but your application needs to respect SIG term in order for it to fail gracefully.
So you specify both memory and target memory, percentage, target percentage, and
I believe you can only scale, specify one at a time. I'd have to double check on that though. Great, so let's go back to our Cloud Shell and deploy what we just looked at. kubectl apply-f 01 Redis. You can use apply-f on an entire directory and it'll deploy all the YAML files in that directory. It's pretty handy. In this case, each one of those objects was coded to be scoped to the K8s workshop namespace. So we should see pods that get created. If we add the -n flag, and your namespace will tab autocomplete as well, which is awesome. So we see creating, yes?
How does it know which order to apply when you do it from the direct?
It doesn't.
Oh, so you have to name it in a way that, like you can create the service before you create the class.
You can. So if you upload the service before you upload the deployment, then there will be no matching deployments based on the selectors. So the service will get created, but it won't route traffic anywhere. So if in that example, it doesn't really matter the order. There are some situations where the order does matter, and those have to be managed out of band. For example, we couldn't upload these without having created the namespace first. If we do get pods, so great, our Redis replica is running. If we do get pods without passing in the -n, it's looking in the default namespace. We won't see anything. That's expected. But we can edit our context so that we don't need to type -n K8s workshop every time. We can edit that either directly from the .cube/config file. We can edit that YAML directly, but you can also do it from the command line. If I do get context, so that asterisk, these are all the contexts that I have in my kube config. If you've been using GKE before, you may see a lot more. Mine often gets pretty crowded. You can see there's a star, that's always next to the current one. So what I'm going to do here is select the first field, which is the name of the context. It also is the name of the cluster. I'm going to edit this context to make the K8s workshop namespace the namespace that this context addresses. So it's kubectl config set context, the name of the context, and then add namespace, K8s workshop. So after this, my kube config will be configured so that when I do a get pods without a namespace attached, it's looking in the K8s workshop namespace. Namespaces and context can be very powerful when you're working with a lot of different workloads in Kubernetes, or context can be especially powerful if you're dealing with multiple clusters at one time. The context, they'll if you're dealing with multiple clusters, they'll all get crammed into one kube config if you're not doing some extra work. So setting context, maybe a production context or a staging context or a QA context, would be very helpful to your workflow.
But there was only one context, right? Why did we have to select it?
You mean why did the command select it?
Yeah, so when you did the get context, the output only shows one context.
Right.
So why do we have to select it?
In the case where there are multiple contexts, the command is the same, right? You would need to have the context. You mean like why doesn't it know that there's just one?
Right.
It's not built that way. Short answer. It requires that argument. Any questions about configuring the kubeconfig context? Yes.
What defines, how is the default namespace selected? Is it what's created at the time of creation of the cluster, or?
Yes, so there are three namespaces created when the cluster is created: the kube system, kube public, and default. And default, aptly named, is where everything goes if you don't specify anything else. Cool. So where are we? Now we can deploy the web app. Let's go to our handy dandy Git UI, and we'll look at the web app. These should look familiar. We have a config map, or we have a deployment and a service. The deployment itself is slightly more complicated than the previous. In this case, we have an annotation, Flex Weaveworks automated. I'm not sure why that's there. Somebody else did that. Our service, or our pod label, we're labeling this pod web app. We have to name web app. The container, the image, that should look the same. In this case, we say we're running this command. This is essentially Docker run or Docker entry point from this command when it starts up. The image pull policy, if not present. What that means is it will pull the image if it doesn't already exist on the VM. If we were iterating on this image and we uploaded a new image to the container repository and then we restarted our pod, it wouldn't get the new image. If you wanted to get the new image every time, pull policy always. Also here, we've configured a liveness probe. So what that means is it's a health check on the service. There's also something called a readiness probe. In this case, this does both. But this is how Kubernetes detects that your pod is running and doing what it should be doing. It will allow to fail 3 times, but it's doing an HTTP GET on the port 8080 inside the container. It'll wait 3 seconds for startup. It'll scan every 3 seconds. If it succeeds once, then it's healthy, and it will allow it to time out 1 second. But that's how Kubernetes can know that the pod is healthy and kill it if it's not healthy, and then have it get restarted. Yes?
Yeah, so the image pull policy is not present, and if we have autoscaling enabled and we get to a point where Google automatically tries to create new instances for us, at that point is it possible that we have 2 different images on the existing cluster versus the new ones?
That could happen.
Only in the case that you're using something like latest.
I mean,
Right? Like the way you would want to do this
Yes.
for an application is to basically have like a SHA or something.
Absolutely,
like that.
yes.
Yeah.
Correct.
Whenever someone asks a question, can you repeat it? Because I have no idea what you're saying.
I will do that, yes. Sorry. In this case, we are also defining a container port, and we are mounting a volume from a secret file. We'll look at the secret in a moment. This env should look familiar. These are our hard-coded environment variables being set on the deployment. But we are also pulling, in these 2 cases, from a config map and a secret. So we haven't looked at those yet. We will momentarily. The secret is saying, from the secret named web app, pull value 1 and set it as secret 1. And in this case, we're saying from our config map named web app, pull the key app dependency URL and name it dependency URL in the environment. So this is equivalent to hard coding in your application configuration, and this is equivalent to having a more dynamic configuration store. In this case, the secrets and the config maps are being stored inside the namespace. So between namespaces, you don't need to change your deployment, but just your config map. Any questions on that? Why that's powerful? Yes?
When we are saying dynamic, like after deployment of the container, and once the container got spinned up, so if you change the config map, does it change the EMB of the container?
So the question is, if you change the config map, does it automatically change the environment inside the container? And the answer is no. You need to restart the pod in order for that to happen. No within limitations. If you configure your application, there are configuration options, things you can do with your application to make it live restart in that way, but by default the answer is no. Before we jump out of this file, let's look at the resources as well to discuss the difference between limits and requests. Yes?
Is there a way to update the config map from a running container?
Is there a way to update the config map from a running container? Yes, if your process has access to the API. That feels like a bad idea. To have a running application change configuration. I think a config map might be the wrong way to do that, but I think that's kind of implementation specific. Essentially, you can configure each pod to have access to the Kubernetes API and do whatever it wants. I wouldn't recommend it, but you can set it up that way. So short answer, yes. Resources and limits. So resources sort of define the size and shape of the pod that's going to be deployed, or the container that's going to be deployed. Yes?
Is there a way to share the config map across different namespaces?
No.
Is there recommendation based on
We can talk after. I think that's going to be something pretty specific to your use case. So resource and limits, sorry. Requests define the size and shape for scheduling. So Kubernetes API is going to say, I want 200 milli CPUs and 300 megabytes of memory. Find me that space. And the Kube API is going to talk to the kubelets and find a node that will volunteer its resources, say, yes, I have something that is that size and shape. We can schedule a pod here. That's just scheduling. It's just about scheduling. Once it's scheduled, the requests sort of don't matter. Limits, on the other hand, that is your overhead for when Kubernetes and the C groups that it sets for your running containers, it can decide what to do with you. If you are utilizing too much, it can scale. That's how limits are set. So the auto-scaling, horizontal pod autoscalers are queued to look at limits. But also, if horizontal pod autoscaling is not set up and your pod is getting greedy, it can kill your pod. If it's running trying to get more memory than it's allowed or trying to get more CPU than it's allowed, it can kill it. Now, in most cases where the way the C groups are set up, the application running in the container shouldn't see more memory than it can utilize, but in certain situations like Java programs, the JVM can detect the amount of memory that's on the machine and try and grab all of it or half of it as it's default configured to do. In that case, Kubernetes can shoot it in the head. Setting and configuring requests and limits can be interesting. Your request can be fairly straightforward. It's sort of maybe the average size. You can use requests to over-provision your nodes if you want to. Limits is interesting because if it does a grab, say for example, if your process starts up, pulls in 3 gigs of data in memory, munges it, drops it into a ephemeral cache somewhere, and then it usually happily runs along at about 128 megs. If you set your limit to 256 megs and it tries to pull that data into cache it'll die. It won't be allowed to do that initial work. So request and limit profiling, knowing what your application is doing, is really, really important when you're configuring these values. Yes?
So one gotcha that I ran into, I believe requests are implicit when you declare limits. So even if you don't have requests set, if you have a limit set to let's call it 3000 M, and you don't have those CPUs, you're not going to get a pod, because I believe it also creates requests at the same time to match whatever your limit is.
Which
kind of makes sense when you know how it works in
Yeah, it's a default request. If you don't have a request, it defaults to the limits.
Yeah. So sometimes if you set your limits too high, you run into a situation where you cannot schedule the pod, and that wasn't what you wanted.
Interesting. I haven't run into that, but it sounds like a thing that could happen. But I can neither confirm nor deny that statement. Any questions around requests and limits, resources? We can get pretty deep into it, but we'll just stay high level today. Yes. I'm sorry, I couldn't hear you.
So, if we write to write intensive app, can we have this space as a resource? If it writes long something.
Right, so the question is, can we use disk space as a resource limit? And I believe the answer is yes, but I can check. I'm confident that it is, but I'm not 100% sure. I think so, yes. Great, so we'll skip over this deployment, look at the secret and the config map. This is a very simple object, essentially. It says, make these configuration variables available through this config map, which we saw how it was accessed in the deployment file. In this case, these values kind of don't matter for what we're doing. They're dummy values, but just as an example of the shape and size of a config map. You can add all the same metadata to this as you want to, but it's a key value store, essentially. In this case, plain text key value store. In the case of a secret, it's also a key value store, but these are base 64 encoded values. When you're dealing with secrets in Kubernetes, the default behavior is an unencrypted etcd with these clear text, relatively clear text. It's called opaque because it's in base 64 encoded, but that's not secure. So be aware, it takes a lot of configuration to get around that and a lot of application work, but essentially secrets are just base 64 encoded text and unencrypted data store in etcd. It's also essentially, this is essentially a key value store that you access slightly differently than you do the config map, but in a very similar way. And we'll look at network policy in a bit. Both of the applications we're deploying do have network policy associated with them. So let's go back to our terminal, do kubectl apply -f o2 web app. So in this case, if you notice, none of the objects in the web app directory specified a namespace. If we hadn't reconfigured our context, they would all go to the default namespace. We did reconfigure our context, so now they're targeted to the Kate's Workshop namespace. I'm also going to apply the default network policy to be fully transparent and functional. While that is going, let's go back and look at the web app service. So in this case, we have a service of type load balancer. So this is going to create a cloud load balancer in GKE for this service. So when it's done configuring, we'll have an external IP address from which we can access the instances of the web app that are running inside the Kate's Workshop namespace. Just like the labels and selectors in the Redis we looked at, well, this is quite a bit more simple. This service has a label app web app, and it's going to route traffic to any pod that has the label app web app. So the selector is saying, pods that have app web app in their labels, we're going to route traffic to them. And we're going to do so on a port named HTTP, which is serving on 80 through the load balancer. Yes?
Is the target port supposed to be a port extension? Target port.
Yes. Is it? Sorry, I didn't hear your question.
It should be a port number.
So that's a good question. The target port, in this case, we're referencing, the question is, should the target port in this be a port number? In this case, we're referencing a port that we named in the deployment, and Kubernetes can know the difference. So we look at the deployment, and we say, here's our port. We're going to route traffic to port 8080 on the port that we named HTTP. So the service is referencing that port.
So you
It's pretty handy, so we don't need to like,
change it in two places.
yeah, and make up port numbers that we know are always going to be available, etc. It's helpful. So while that should be done creating now. If we do kubectl, if I can type, get services, we'll see we have 3 services. We have the Redis primary service and the Redis replica service. Those are of type cluster IP. So those are accessible from inside pods at that IP, but not external to the Kubernetes network. And then we have our web app service of type load balancer. It also has a cluster IP. It also has a node port, 31,171, but importantly it has this external IP. If we can go visit that. So this is how simple the web app is. Hello from Kubernetes. Now it will also interact with Redis. The format here is IP key name, key value. So if we put both, it will set it, and if we just put one, it'll get it. So if we do key value, it's created a key in Redis with the name key and the value. We can retrieve it by just putting in key. It's not very fancy. Any questions about how we just created we uploaded some YAML files, and now we have a load balancer with the public IP. It's pretty nifty. Any questions about that? Yes?
So the app deployment or YAML, the mount after secret is SC secrets. Is that something that we can access from the kernel?
If you exec into the container, you can access it.
Not from the kubectl itself.
No, not directly from kubectl.
And the secret that gets mounted is what's defined as secrets.yaml?
Yes.
Is that correct?
It's the decoded value gets mounted.
So, I couldn't understand where the web server is running. When you get the UI, you're getting a static page. So it's getting again some web server. So, why that is being deployed? You didn't install an HTTP server.
So the question is, like, how did we just upload YAML and get a web service?
Yes.
Kubernetes. So the values that we uploaded in the deployment and the service file defined all of that for us.
So if I want to have some application server, web server, it's a web logic, or web sphere, or anything like that. So in this exercise, where that I would be deploying, where I would be installing this.
So all of the programs are all running inside Docker containers. And the deployment of the Docker container is configured with that deployment.yaml. So the installation of the software happens at the image, the Docker image, and then the creation of the instance happens when you schedule the pod using a deployment. And then you're routing traffic, HTTP or TCP traffic, to it through the definition of the service. So this sort of, the idea behind Kubernetes and containers in general is you never install anything anymore. You don't have to create your own infrastructure to route traffic anymore. You're uploading declarative configuration files, and Kubernetes takes that and says, I know what you want me to do. I'm going to do my best to make the world look like you want it to, come hell or high water.
And same case would be for any database or NoSQL database as well, right?
That raises questions about whether or not it's a good idea to run stateful databases inside Kubernetes, which I lean away from. However, essentially, you can configure Kubernetes to run any program you want it to.
What is the best practices?
Regarding?
And if you have a solution application, who carries application server databases, and there is huge set of very, data flow across the databases. So to use Kubernetes to deploy that kind of environment, so where, what component would be utilized?
I think we're getting into some implementation-specific questions, and we can talk about that after. So I think you probably have a specific use case in mind, which won't be broadly applicable to everybody. But you did remind me, you asked about templating. things like that. So we've created all these objects. You can do a kubectl get deployments, and we'll say these are the deployments we've created. Now I want to, we can get it back out as YAML. So in this case, I say kubectl get deployment. Whoops, doing that wrong. We'll get the web app deployment. And we're saying we're going to output that as YAML. So in this case, all of the values that we uploaded, we can then retrieve as YAML with some extra stuff. So if you have a deployment or a web application, or if you do a kubectl create or kubectl run, you can then use -o YAML to retrieve that information, similar to the Google UI where you can sort of click through and then get the declarative content. You can create things in the kubectl and then output the declarative content if you want to. Sort of a cheating workaround. Let's see, where are we? So, yes.
So, where do the application logs exist? Do they exist in the individual pods when the app is running, or does it exist in a centralized place where we can view all the application logs together?
The application, I'm sorry, I couldn't quite hear that.
Logs.
So in GKE specifically, all the logs are automatically shipped to Stackdriver logging. The logs are pod specific. So if you want to look at logs, for an individual instance, oops, how do I do that? Oh, it's fighting me. So if I want to look at logs for an individual pod, I can select that pod, kubectl log pod name, and this is all the logs from that pod from the beginning of time. There are certain flags you can use. -f is nice because it's a follow. It's like a tail. You can slice the logs using different flags as well. So that's accessing logs for an individual pod. If you get paged for whatever reason, or you just want to see what's going on in one pod, you're experimenting, that's useful. It's probably more useful, and we can't go, I don't have time to go too deeply into it, but you can get to the logs through the UI and through Stackdriver as well. Let's see. Oh, I'm a little off today.
You got to click on the manage pods.
Sorry, where?
Click on the manage pods.
Oh.
Yeah. There's a view logs.
Oh, there you go. Thank you very much. So you can get done from the UI as well, if you choose to.
So this is common, it's not specific to a pod, this is common across the application.
No, this is one pod.
Yeah, logging is per pod. So per instance, the same way as it would be in any other application, like typically you're not having multiple PIDs logging to the same location for your service. Or maybe you are, but it's not how I've done it. So each pod, and indeed each container inside the pod, has its own specific logging out.
Okay, so if I have a web request coming in and I have 20 different pods that can take the request and process it, and if one request fails, I need to go to each pod to figure out what failed and what failed?
In that case, I'd recommend you go to your centralized logging server that you set up like a good ops person, and you do a search there. If you don't have that, because you're early in your investigation, it's more of a proof of concept sort of thing, there are other tools you can use to tail or to aggregate logs from multiple pods. It's not a native kubectl thing, though. So let's see, it's getting around noon. We have some more things to talk about. So we looked at the horizontal pod autoscaler for the Redis one. We'll look at it for the web app as well. So in this case, we're saying up to 50 replicas So the question is like, how do we, what is that doing? What does that actually mean? So horizontal pod autoscalers will create new instances of the pod horizontally when the threshold is reached. So in this case, when the target CPU utilization goes over 30%, it will create a new pod. Earlier question was, how do we scale nodes, right? The cluster autoscaler, which is a process that we tick the button for autoscaling on in the UI, and other Kubernetes creation processes, you may need to may need to manually deploy the cluster autoscaler. But what the cluster autoscaler will do is, when there are pods that cannot be scheduled, it will create new nodes. So it's sort of a two-tier scaling event. We're not directly creating nodes because an application is starved for resources. We're creating new pods because the application is starved for resources. And then Kubernetes is detecting unschedulable pods and adding nodes. There's a lot of black magic that happens underneath the covers. You can configure that in many different ways for scaling behavior. But essentially, when your deployment needs more resources, it will add more pods. And when there's not enough space in your cluster for those pods to be scheduled, Kubernetes, the cluster autoscaler, will add more nodes. And that will scale up and down depending on the behavior you have configured. Any questions about? Yes?
If there are pending pods, are there any priorities assigned to different pods, so a pod can replace the other pod?
I'm sorry, I missed the question.
If there are pending pods that cannot be deployed, and there are any priority assigned to these pods so that a higher priority pod can replace a lower priority?
So if there are pending pods, it will depend on why they're pending?
No, I mean, it cannot be deployed if it hit the limit of the scale.
Oh yes. So we set a maximum of 6 nodes for our cluster autoscaler. If we deploy 10,000 web app pods, then it will scale up to that limit, and then the rest of the pods will stay pending because the resources aren't available, and we didn't configure it to scale that much. Does that answer your question? Great. So we can, where are we? There we are. If we do kubectl get HPA, horizontal pod autoscaler, if we type kubectl properly, we configured 2 HPAs, one for the Redis replica and one for the web app. We can see that our target is 20% and 30% respectively, and our current utilization is 0%. And so we can look at these configurations. If when we start to see a lot more load, let's see, I believe we have an easy copy and paste to do that. There we go. If anybody wants to grab my external IP and start hitting it from your terminal, as many as you can, we can watch mine scale, or you can do it to yourself. Here's a suggestion. But essentially, we have these configured to be a pretty low utilization threshold, not really realistic for real world. The application does very little, so it's not actually going to stress it. But if we hit it enough times, we can see the number of instances go up, and indeed the number of the target utilization increase as well. So I will try. Nope, having trouble here.
Launcher has AV installed.
It doesn't, but you can apt get it. This is I believe it's a Debian or Ubuntu image underneath. Oh, I always forget that. If anybody knows the command to install, that'd be helpful. probably still not going to find it. In any case, if anybody has written a quick load balance or a quick load test thread, you can go ahead and do that. But we can look at a few more things if we don't get to a scaling event.
I think it's Apache 2-utils.
I think you're, pardon? Great, thank you. That is one of those things that just never sticks in my brain.
Have you managed to download it? All
Yes,
command?
Apache apt-get install Apache 2-utils. And that looks like my command is a little off.
You have an extra scale.
You have used it twice.
Oh, thank you. Cool. While that's running, I'm going to pop open another Cloud Shell instance so we can watch things happen. Cool. So already our percentage is going up.
What's your IP again? Sorry.
It is 35-202-29-172.
I'm giving you a little load.
Pardon?
I'm giving you some load.
Oh, super. Yes.
So the, couldn't find the, it says the AD command on the phone. Is that Apache then?
Yeah, it's not automatically installed on the Cloud Shell, so we installed it using apt-get and Apache 2-utils. We probably have enough to hit targets now. So you can see our replicas have already started to increase. So we have 2 instances of the web app. One's been running for 19 minutes, one's been running for 2 minutes since we started the load testing. You can use not dash a dash W. The dash W flag will watch and iterate so that it, as new instances get added. While that's going, hopefully we can get to a large number of instances. Let's look at network policy a little bit while we're trying to break things. We start by deploying this default network policy. This is our default deny, saying don't allow anybody to do anything, especially the ingress. We turned on network policy as a checkbox in the console, and that allows this to work. It changes the underlying network overlay. So we call this default deny in the Kate's Workshop namespace, saying for a blank pod selector, so for any pods, and this is on ingress traffic only, we're denying everything. Then for our individual services, this network policy is saying allow ingress from pods labeled web app on this port, TCP 6379. So because we have network policy enabled, in this case, no other pod that isn't a web app pod will be able to talk to this Redis pod. So that's useful when you want to limit what services pods can talk to.
Question.
Yes.
Does that mean only when you're sending a request through an ingress controller endpoint?
It's confusing terminology, and no, it's only inbound traffic.
Okay. So this is ingress, like we just have overloaded term.
Yes.
Okay.
Yeah, so the ingress here is not of the ingress object type. The ingress here means inbound traffic. I think they defined network policy before they thought about their terminology too much. Likewise, if we look at the web app, we have network policy here. And this is allowing inbound traffic again, from anywhere to our web app pods. If we change this, if we make this not available from anywhere, we give it a specific IP address, this is essentially creating a firewall inside the cluster, as opposed to a firewall on the load balancer itself. So if you try to access this with a specific IP here, then you would be able to connect to the load balancer, but the load balancer wouldn't, the service would not connect, would not allow any traffic from the load balancer. This is one way to control traffic inside the Kubernetes cluster. Pre-Istio with network policy, this is the way that you might have that sort of authorization security boundaries between your services. You can get really complicated, as with anything. High level, we are open to the world for web app, and the Redis can't talk to anything or won't allow traffic inbound from anything except our web app pods. Yes?
And here the enforcement layer is the CNI plugin?
Yes.
Okay.
This is controlled at the internal network plugin, the internal overlay network that's configured in Kubernetes and Google. Yes?
So does that mean we can also apply on the type of the network?
Yes. Under the covers in most CNI plugins, not all of them, but under the covers in most of them, this is all IP tables rules on the nodes. So anything you can do with IP tables, you could theoretically do with this network policy, if you have the right switch knob to configure it. Let's see, how many pods? Look at all that. We have a couple more pods creating. See, some are pending. What's our count now? Let's see. We did our network policy. We can try, and we're finished up a little early for the morning anyway. I can ramble about other topics before we break into Istio for later, or we can break early and be gone for a lot longer. You can flood me with questions. Questions.
I just wanted to point out just a couple of questions around like how do we know what to put in the YAML files. Kubectl explain is pretty good
Yep.
about like just diving into each individual component of whatever API object you're trying to create with a YAML.
That's a good
That can
clarification,
really
yeah. So the question, or the statement was, kubectl explain can help explain each object and give you a lot more information than I can probably out of my brain today. And it may be in a more digestible format than the docs, but at least it's right there in your command line. So that's something to look at. Good, thank you for that. Yes?
How do I connect with my local kubectl to the Google cluster?
So if you are configured for your workspace to connect to your Google project, then you can copy that command out of the connect window and just paste it into your local, and it'll be configured exactly the same. Other questions? Yes?
So the cloud console that you're issuing the command is not the master. Master is somewhere else. Is that right?
Correct. The Cloud Console is really just the user interface to GCP as a whole. That may issue commands to the master, but I wouldn't count on it. You can interact with almost all of the objects that we have been using for kubectl through the UI. I don't do it very much. Most operations people hate UIs, and I'm one of those. So I do all of my interaction through kubectl and the command line, or through a handful of other tools that we use on a daily basis. But if you need to show your manager, or you need to prove this to the board, you have these GUI tools available to you, including logging. In fact, why don't we look at stack driver logging real quick? It's killing me. Cloud functions, I'm forgetting where this is. There we go. So the question earlier about how do I look at logs for multiple instances, multiple pods at one time. This is something, so GKE provides this for you. If you're not using GKE for any reason, or you have your own paper trail or your own EFK stack or anything else using Datadog logging, etc., you can forward these logs to them as well. But in this case, I'm looking at the GKE containers for basically every container running. So this would cover multiple clusters as well. I can choose an individual cluster. It's another UI for a logging search tool. Let's see if maybe we can look at logs specifically from the web app. That's not from the web app, but it's pertaining to the web app. So if you're running on GKE, you get that for free. If you're not running on GKE, you'll have to set it up for yourself. But this is how I would suggest you look at, when you want to look at logs for multiple containers at once, this is the place. Is anybody not running log shipping in production at this point? Good.
Do you know how this works behind the scenes?
Pardon?
Do you know how this works behind the scenes? Is it pulling logs from each container itself and displaying in the common phase? Or are the logs themselves stored in like separate days?
Oh, I'm not sure specifically how Stackdriver ships logs, but speaking about container logging in general for these, you can access the FluentD is one that we use a lot in all of our clusters, and it accesses the container logs from standard out and ships them to wherever we configure and can do some processing on it. It's essentially the same thing, functionally the same thing as Logstash, where it's taking logs from different sources and outputting them and forwarding them to this data store. This is not pulling directly from the disks that are connected to, or the volumes that are inside those pods. It's reading it from the logging API. Any other questions or things you'd like me to dive a little more deeply into that we looked at and we've glossed over too quickly?
Yeah.
Yes.
Last few commands for scaling was too quick to capture.
Pardon?
Last few commands were too quick to catch it, mainly to install Apache util, and then I lost it.
Okay, so the commands that we did to install Apache util aren't important to the demonstration, but what we need to know is that we applied load, and thanks from get by with a little help from my friends, we applied some load, and then we started to look at the events that were taking place. So in that case, I did a kubectl get HPA, or horizontal pod autoscaler, so we could monitor the target utilization, or the percentage of utilization, and then the target utilization, and then also the number of replicas that exist of each one. So getting the HPA is useful for that. We can also get, if we do a describe on the deployment, yep. If I had a nickel for every time. If we describe the deployment web app, we'll get a lot of information. It'll go over a lot of what we already know that we uploaded, but it will also give us a section called events at the bottom once it gets there. And that can be a good way to investigate scaling events or any events about if your pod is failing to start for some reason. You can look there and it will give you information. It's separate from the logs. It's more the kube system logs. Oh, whoopee. I'm going to get bit by the demo gods today.
Can you look at the workloads
in the UI?
user interface?
You can. There's a good chance that we've overwhelmed my cluster. That's not a good sign. Oh, it's being updated. How handy. Automatic cluster upgrades in the middle of a demo.
What is your kubectl top node?
Top node. I probably won't be able to connect to it because I can't get to the API. That's a good command. While we're just throwing out random knowledge now, you can you can do kubectl top, and it'll give you some information about resource utilization. There we go. So we can look at the amount of CPU that's available and the amount of percentage utilization and memory utilization for each one of the nodes in our target pool. So I have 6 nodes. That was our maximum size. So I'm probably having trouble because I'm just totally out of resources in my cluster.
That's it.
Yes.
So in this example, for example, we have a web app backed by Redis, right?
Yes.
So if I spin up services like this, is there like a centralized dashboard that Kubernetes provides where I can look at the status of everything, like how my Redis is doing, how my server is doing, like IOPS, everything, stuff like that?
Not really. It's the sort of a thing, you're asking for a monitoring dashboard.
Yes.
And while Kubernetes does provide, not Kubernetes specifically, GKE provides some monitoring tools. Kubernetes provides you with a set of tools, but for what you're asking, I'd probably recommend a third-party monitoring software. ReactiveOps, we use Datadog, which is great. Sysdig is also great. You might be able to get that information out of Stackdriver monitoring in some meaningful way. Because we use Datadog, we don't rely on Stackdriver monitoring, so I don't think I'm prepared to discuss that overly deeply. But it is a nice baseline, a nice handy, like out of the box. So if you want information about all of your nodes and all of your Kubernetes workloads and pod logging, that sounds like something. I know it's something Datadog can do and does well, but it's an external
So
tool.
how does that work? So to use Datadog, I need a client running on each one of the pods, right? Is there a way I can go and install those, or can that be part of the Docker image itself?
I think that if you're running an agent for a monitoring software, it'll be running on the node, not inside the pod necessarily. And it really is implementation specific. So like New Relic, you're going to implement totally different than you would Datadog, and that you may have application specific libraries you're including so you get New Relic information. So I think it's really specific to your use case. You had something.
Yeah, I was gonna say the Kubernetes dashboard provides you like a quick, like a at a glance overview of like all of the objects in your Kubernetes cluster and whether or not they're ready. And then there's like a moving 15-minute window of like the CPU and memory usage, but like that's about it. So for monitoring anything beyond that, any instrumentation things, it's all gonna be an external concern.
Yeah, exactly. So the point being brought up is that the Kubernetes dashboard does provide a certain amount of information at a high level, at a sort of a rolling window, but it's not. I don't think it's what you're looking for in a high level dashboard.
Oh yeah, I was just asking more generic question. I'm new to all this.
Yeah, great. And I think we did tick a box in the when you created the cluster that we are running the Kubernetes dashboard. I don't use the Kubernetes dashboard very much. Again, I'm mostly a command line person when I do the work, so I don't feel prepared to walk you through the dashboard. But it's a nice UI for things that people like UIs for. Yes.
So in the web app deployment, we only specified the license probe.
Mm-hmm.
So what happens with the readiness probe? Is it like the same? And what's the use case for having two different probes?
That's a good question. The liveness probe controls whether or not Kubernetes allows the pod to stay. If say, yes, you're running, you're doing your thing. The readiness probe is the circuit breaker for the service. So if you have one of those services that takes 10 minutes to start up for some reason, it's loading a bunch of stuff into memory, whatever, but it's you don't want Kubernetes to kill it because it's not ready yet. You want it to, it's alive. So you have a liveness probe saying, yes, this PID is running, the process is running, whatever the appropriate check is. That's great. So it's running, but it's not ready yet, so don't route traffic there. So that's the delineation between liveness and readiness. Liveness says, please leave this pod alone, it's healthy. Readiness says, but don't route any traffic to it yet, or do when it is ready.
What type of probes can we utilize beyond like a HTTP call?
You can do network calls, HTTP or TCP, and you can do exec. You can exec inside the container or inside the pod. For HTTP, you can configure it, but by default it expects a 200. For TCP, it's really just, can I open this port? And then exec, it's on the exit code. Yes?
Just wondering, using this liveness and readiness problem, could we create a dependency graph the way Kubernetes mods? In a sense, I have a service, a front-end service, and I have a DB. Can I say that my front-end service should wait for DB to come up and then start something?
That sort of orchestration isn't really native. You could build tooling around it. The question is, can we do dependency graphs so that we, like, if I'm right, you're saying wait for the database to become available, then start up the web app, and then.
Then initialize the pod creation.
So you want it to block you want to make sure the database is available before you start creating your pod, so you want it to block. Yes and no. So the way that I think you're thinking about it, it's not really going to do natively, but what you can do is have your application pod fail when it can't access the database. And so it'll drop into a restart loop until the database comes up. And you can configure that behavior to make it not heinous. But, yes?
I was addressing that. One of the things that we do is for our local development in Kubernetes, in the entry point script, we basically do like a while loop. So like until that port is available on the endpoint that you've configured it to look for say the database, it's just gonna sleep 3 seconds and then do it again and then again. And then once the database has become available, then we would move on to the additional like maybe 3 steps for the given container before it runs the application.
Yeah.
So like the entry point script might be the area that you can look at there.
That's an application solution to that. You can also use in the same, essentially the same process. Deployments can have what are called init containers, and have it doesn't run in the pod, but you can do things to while the pod is initializing. That init container can write to disk and it can make calls. So you can have an init container that blocks in that way, so you don't have to build that into your application pod, your application image. But those are sort of application solutions to an orchestration issue, which isn't native. You're basically coming up with solutions. It's not a dependency cyclic graph you can put into Kubernetes and have Kubernetes do that intelligence for you. That make sense? Great. Yes?
So just like because of the load, the queue system itself was kind of overwhelmed while creating the nodes and stuff like that.
Mm-hmm.
Is it possible for you to run the queue system and other namespaces in different node groups rather than run them with the app, so that they don't? So I could have like 3 or 4 different workloads. I don't want one node and one, basically messing with the queue system itself.
The short answer is yes. It takes quite a bit of configuration using selectors and scheduling preferences in your deployments, but you could have node groups and have your deployments specify through a series of different configurations. Have your deployments say, don't schedule me on cubes on nodes that are reserved for system containers.
So you can't say this namespace can only run in these node groups.
I don't think so. I haven't come across that, so I don't think that's possible to do it by the namespace. But what you would do is you would only deploy things into that namespace that you also apply these scheduling selectors to. Does that make sense? Yeah. So there's a lot of knobs and dials that we're not addressing very deeply today, but one of them is node selectors and scheduling preference. There's a lot around that. Well, okay. Well, I guess I've run out of things to talk about this morning. Unless anybody else has more questions, we can